Hello, everyone, and just want to welcome James to this evening's presentation in relation to fire stopping, a practical insight for engineers. Just to let you know, James himself is a graduate civil engineer and has completed his master's associated with the University of Ulster. From there, he went on to work with Michael Slattery's and Associates for a while, and just there in more recent years, he's worked with Crossfire specialists contracts there, and he works to advance the fire safety standards and the best practice in all the industries. So there's a wealth of experience and wealth of knowledge there. So I'm looking forward to this evening's presentation. So James, if you just want to take over the slides there,
yeah,
you can start to talk. Thank you
thank
very
you,
much.
Sinead. So today's topic is going to be on the practical insights for engineers. So the overview, a bit of my background, Sinead covered a lot of it there. Anyway, Crossfire's history. We'll look about what is fire stopping, the regulations and requirements, BCAR fire stopping, test the details, third-party accreditation, and common site scenarios, finishing with a short Q&A at the end. I just want to iterate at the start that it's not my mission to try and persuade you that Crossfire are perfect and that our competitors aren't. It is my mission along with Crossfire is to raise awareness on fire stopping, the importance of fire stopping, and how we can improve it going forward through channels of early engagement and communication. So my background, I started fire stopping part-time to Crossfire during the summer months in 2014. It opened my insights to working on building sites and to talking to engineers, and believed that with my small knowledge on fire stopping and the fire engineering route may be suited for me. 2016, I started civil engineering at Ulster University and was honoured to get a placement year with Michael Slattery Associates. At MSA, I got a fundamental knowledge for fire engineering and proceeded to pursue my education and finishing the civil engineering degree, and then commencing the fire safety engineering degree at Ulster University. Following that, I went back to Michael Slattery Associates for 2 years until I returned back to my roots at Crossfire to help with a company local in my town. So who are Crossfire? They're established in 2012 as Crossfire's passive fire protection. They achieved fire asset accreditation in 2014. After a major increase in remedial projects, they rebranded as Crossfire Specialist Contracts in 2016. Today, we have at least 25 plus live sites throughout the UK and Ireland. Some notable projects being the Loft Lines project, that's what's pictured on the screen. 780 new apartments at the Titanic Quarter in Belfast City. We also have Sports Direct in the Ilex Centre, a new innovative store for Sports Direct, covering 5 floors of retail incorporating many of their different brands. We work on major data centre projects throughout Dublin and London, and we have numerous remedial projects which have a confidentiality requirement and prefer not to be mentioned. So what is fire stopping? It's used for sealing apertures and imperfections of fit or design tolerance between fire-resistant walls, floors, and ceilings to restrict the passage of fire and smoke. Fire stopping products should generally have at least the same fire resistance as the separating elements into which they are installed. As you can see from the diagram there are many different types of fire stopping products. We'll get into the different products more into the presentation, but if you look at the back there, we've blue fire pillows. To the right of that, we have a PVC pipe that's been protected by the means of a fire collar. To the right of that, we've got a multi-service opening. And then you can also note the importance of the service supports, which we'll touch on more throughout the presentation. On the floor there, we can see a sleeve on a single pipe penetrating, and then a shutter and compound seal on the ground there. There's wrap and lock combustible pipes. They're different methods of fire stopping. You can see that between the wall and floor junction, there's an FJ400 linear gap seal. This allows for the movement between the concrete floor and the external masonry wall. And then in the cavity of the wall, we have a cavity barrier. So as you can see, there is a diverse range of products that are required to complete many different functions, but ultimately the same vision of protecting lives in the event of a fire. So integrity and insulation. So when Crossfire gets a specification, it should usually include the fire resistance rating, including the required insulation integrity classification, i.e. 60/60 or 30/15. Integrity refers to an element of system's ability to stop the flames or hot gases of a fire from physically passing from one side of the element to the other side through holes, gaps, cracks, or any other types of openings. That's what the first diagram on the right shows. You can see that the heat makes its way through the wall, whereas flames and hot gases remains at the fire side. Insulation refers to an element or system's ability to limit the surface temperature rise on the non-fire side of the element for the denoted duration during which the fire side is exposed to a fully developed fire. As you can see in the diagram to the right, it's cooler on the left-hand side of the wall than it is on the right. Moving on to regulations and requirements. Fire protection is intended to preserve life and property. Effective fire stopping and fire resistance separating elements plays a critical role in containing a fire at its source. Major threat from fire in most buildings occurs when concealed cavities between fire separating walls and floors are interlinked. It is essential that all openings, gaps, or fire stop to restrict lateral and vertical fire spread. We have our trusted TGDB, famous document in Ireland. It has been updated to a 2024 version, which has since released the introduction of EN 13501 for new building elements, while retaining the old BS 476 for existing building elements. So mechanical and electrical services by necessity breach compartment walls and floors, resulting in a failure of integrity and insulation to occur where gaps or in services have not been adequately fire stopped. Building regulations in Ireland are applicable to most buildings that work is undertaken on. In Ireland, TGDB is used as a guidance starting to comply with the second schedule of building regulations, 1997 as amended. So in recent years, BCAR, or maybe 11 years ago now, BCAR is introduced. It's introduced 2014 to strengthen the building control system and ensure compliance with building standards. BCAR requires a certificate of compliance and completion for all building projects. This certificate ensures that the building has been constructed in accordance with approved plans and specifications, including fire stop measures. Registered professionals, whether it be an architect, an engineer, or a building surveyor, are responsible for inspecting the building and ensuring that the work is in compliance with the building regulations, including fire safety. Fire stop must be considered at the design stage and detailed in construction drawings. We get into this later on in the presentation with regards to early engagement, but during construction, fire stopping installations must be inspected and verified for compliance with the specified standards. So in terms of the fire stopping and BCAR includes regular inspections, whether it be by the engineer, the architect, the assigned certifier. Along with the building contractor, they must carry out regular inspections to ensure that fire stopping installations meet the required standards set out in the approved fire safety certificate. Documentation is also important for BCAR, as detailed records of all inspections, tests, certifications, and these must be maintained and submitted as part of the compliance process. This documentation includes the installation of fire stopping products, inspection reports, test certificates, scope of works, marked up drawings. Upon completion of the building project, the assigned certifier must sign off the certificate of compliance and completion, confirm that all fire safety measures, including fire stopping, have been properly implemented and inspected. By adhering to the BCAR requirements, all stakeholders in the construction process can ensure that fire stopping measures are effectively implemented, verified, and documented. This helps to protect building occupants, property, and the integrity of the building. So what's required from the fire stop in terms of BCAR? This is based on my own experience of completing BCAR projects within Ireland. So we provide a cover letter explaining the scope of our works, what we've done, where we've done it to, what standard of fire rating, or what fire rating are we providing, what standard this fire rating was tested to. Data sheets of all our products installed, including technical data sheets, European technical assessments, declaration of performances. We also supply installation reports. So photographic report illustrating the location of all fire stopping installed, along with the relevant installation details, i.e. size, penetrating services, fire rating, seal IDs, location. We provide a CS certificate with most subcontractors. This certificate confirms that the building or works have been completed in accordance with approved design and comply with the building regulations. It should be signed by the director of the company and reference all fire safety certificate drawings. Third-party accredited certificate. Crossfire also provide a third-party accredited certificate under the Fire Act scheme. This certificate is to illustrate that the fire stopping is completed to comply with the Fire Act comprehensive rules and regulations. As you can see on the right there, I took a screen grab of one of our current sites which shows a marked up drawing. All them green pins are locations where fire stopping is completed. Within Crossfire, we provide the main contractor a login to a fire stopping recording system to be able to review progress, carry out spot checks of the work. Previously, we've also given this login to the project fire engineer, project architect, and project assigned certifier. This enables full accountability and transparency. So the tested details. So Firestopping products are tested to BSEN 1366 and or BS 476. From this testing, the fire performance of the product is determined. It's critical that all products are installed in strict accordance with the manufacturer's tested detail in order to be certain that the product will resist smoke and flames in the event of a fire. And to the right, you can see that the different services being tested in the partition. Take note, service reports. This is a big ticket item at the moment. Due to the location of these service reports must be installed on site within 300 to 400 mil of the threshold. This also prevents other things such as services from twisting under fires and damaging the fire stopping. You can also see that there's certain distances between each of the services and the thickness of the HP mastic around the combustible PVC pipes. You can see the size of cable bunches there that are being tested and the different types of services that they're testing. What are the main fire protection testing documents? Test report. Test reports characterize fire resistance of a building element and include raw results. Reports describe everything that happened during the specific fire test. They provide the temperature evolution of every seal, which afterwards can be expressed as a fire rating. Then we get a classification report. This is based on one or multiple fire tests. These reports validate the fire performance of products and building materials. Classification reports are issued by a third-party accredited organisation in accordance with the standards approved by several independent laboratories. A European Technical Assessment, an ETA. European Technical Assessment is established by the Construction Product Regulation. ETA is issued by a technical assessment body upon the request of a manufacturer using a European assessment document, which is the basis for writing an ETA. Sorry, 2 seconds. As far as I'm aware, there still isn't a harmonized standard yet for Firestopping products, and therefore CE certification is not mandatory. However, a lot of manufacturers voluntarily get CE certification for their products by way of getting ahead of the curve. A European assessment document is a harmonized technical specification developed by EOTA as the basis for the European technical assessment. In combination with the ETA, the European assessment document provides manufacturers a way to CE marking for construction products that are not fully covered by a harmonized European standard under the Construction Products Regulation. This is something we've came across in the past, where fire consultants have been adamant for a CE certificate for certain Firestopping products. However, they're not harmonized, and on that basis, they're not mandatory. We've explained that to the fire engineer, but he wouldn't back down. It's very difficult to get an alternative product for the scenario on site, and it's something that we'll touch base further on the presentation. So there's the cover page of an ETA. I'm pretty sure a lot of you'd be familiar with that page. This cover page ETA document illustrates the European assessment document that it complies with, EAD 35045001104. The image on the right is taken from that ETA document. It illustrates the important information for the opening that must be complied with when installing the Firestopping: penetrating services, substrate type, maximum opening size, buttering requirements, completing the Firestopping in as few pieces as possible, and service reports. So on site, if these aren't complied with, technically speaking, it's not a compliant Firestop. The criteria for selecting a Firestopping product or system: the location of the opening. Is a wall, is a floor? Will it be seen? Will it be hid by a ceiling? If it is a floor, is it load bearing? Will you need compound in to a depth of 100 mil for load bearing requirement? What is the fire resistance rated? How big is the opening? Will it need framed out? Will it need service supports? Is movement required in the fire stop? Is there a deflection requirement of the wall? What kind and type of services are penetrating the opening? How many services are there? Is it a multi-service open? What is the size of each service? Are they in compliance with the requirements of the ETA? How close are the services positioned to each other? And the opening, is there enough service spacing Does it comply with the European Technical Assessment? How far away from the service supports? How far away are the service supports from the opening? Is the fire stopping system suitable for the use within the intended elements of construction? Is the installation accessible from both sides? Does the seal have any other further requirements, i.e. air, acoustic, water resistance? These are all points contractors at Crossfire must consider when installing fire stopping. However, from experience, there are some scenarios where other parties force your answer, i.e. where it might be cheaper to install a collar around a UPVC pipe. You have to install a Patterson or wrap because the plumber has used a claw hammer to open up the hole within the metal stud partition. Early engagement could help prevent these errors. There's just that slide. So I mentioned early engagement a few times throughout this slide, and it's something I do try to push, especially with my existing clients. Additionally, from the view of the main contractor, procurement has been carried out in order of the procurement value of each package. This meant that because fire stopping is a smaller value than other packages, such as the mechanical and electrical packages, the stud partition package, the concrete package, wasn't considered until several months into the project. Early engagement refers to involving the fire stopping manufacturer or contractor at the initial stages of design rather than an afterthought. There are many benefits of early engagement. It saves lives. First and foremost, the ultimate reason fire stopping needs to be compliant is to save lives. From a tender perspective, once all parties agree upon and understand the design, the risk is mitigated, providing peace of mind. Test the details. Initiating early engagement increases flexibility when designing services. This flexibility makes it easier to choose a tested solution based on what has already been tested. Ensures compliant and achievable installations. Considering service penetration sealing at an early stage will also facilitate work at the installation stage. Allows more time for parties to utilise the support offered by the manufacturer and prepare installation. Allows the contractor to prepare labour, materials, access equipment, and other wee bits and pieces to be able to complete the job successfully. Also, most importantly for a lot of projects currently, it helps avoid extra costs and delays. To ensure buildings are safe and comply with the relevant regulations, fire stopping needs to be designed according to the manufacturer's tested details. Suppose fire stopping is not considered when decisions are made with the location of compartmentation, walls, and central routes of M&E services. In that case, there is no guarantee that the manufacturer will have a tested solution. If these discrepancies come to light too late in the project, stakeholders can face extra costs and delays due to needing to redesign service penetrations. For fire engineers in this project, or fire engineers in this presentation, how many times have you had fire stopping contractors complain that they physically can't fire stop in a certain location, i.e. on top of a duct, at the top of 3 rows of pipes, and maybe 2 rows of cable containment? Can they actually get to the top of that square duct? How many times have you came across a scenario where UPV soil pipe penetrates the floor and is half in line with the fire rated partition, which has to be notched out, and the fire stopping builds out layers of firebat to hide it from you? It's happened. I've seen it happen on our sites. Could this have been avoided at design stage? Absolutely. It's third-party accreditation. Third-party accreditation confirms characteristics of a product, process, or organization. So for Crossfire and other fire stopping contractors, third-party accreditors audit our process and how we approach a project, from initial contact from the potential client to the installation site to the handover documents. It's fairly comprehensive, and once compiled, it will ensure safe peace of mind for all project stakeholders, which includes fire engineers, architects, assigned certifiers, and the client. What are the advantages of third-party accreditation? Efficiency, certainty, customer satisfaction, confidence, engagement, and trust. So how do you gain third-party accreditation? So because Crossfire FireAS accredited, I have used the FireAS logo. There are other bodies out there like AFC, BM Trada, and LPCB. Each of the third-party accreditors have their own set of rules and regulations that are fairly comprehensive to which the contractor must align with. Third-party accreditors review your paperwork, they review our paperwork, they review our office systems, our ISO 9001 systems, our health and safety systems. As previously mentioned, the contractor is audited from the initial contact from the client to proof of quotation delivery and storage of materials on site. Installations, they review your supervisor's quality reports and your handover documentation. If there's any errors in any of these documents, there's potential to lose your accreditation. Third-party accreditors review your on-site processes. When you come out onto sites, they review your installs, they review your operatives, they review how we work the site, They review your health and safety, they review the installation, they review the operatives installing it to make sure that's in compliance with the tested details. They review material choice and your proposed details that you intend to install. And they even review your material wastage procedures. After this year, your certificate is issued, and then you get regular audits to ensure you meet the guidelines. You have an office audit and 2 site audits annually. That's as part of the FireAS third-party accreditation scheme. I personally can't speak about the AFC, BMTAD, or LPCB. Engineers' judgments. So as you know yourselves, on sites, there are scenarios where there is no tested detail or detail within an assessment document. Contractor would ask the Firestopping product manufacturer for an engineer's judgment detail. Engineers' judgments are based on a combination of fire test evidence, technical knowledge, and experience. They interpret test results to predict how products will perform in real-world fire scenarios. Engineers' judgments must comply with the requirements of the Passive Fire Protection Form, guide to undertaking technical assessments of fire performance of construction products based on fire test evidence. This means that the product manufacturer must provide a declaration to the contractor signed by a senior member of the manufacturer's technical team. It's Appendix B of that PF guide. How often have you seen this declaration or the engineer's judgment signed by the manufacturer? It's very difficult. I know from experience talking here at Crossfire, it's very difficult to get a manufacturer to sign and test the detail. If this declaration is not signed, it cannot be certified under the FireAS scheme. It is a mighty question of who inherits the responsibility of this fire stop fails. Who stands over a failed engineer's judgment? The Firestopping contractor, the project fire engineer, the assigned certifier. This could have been ironed out at the early engagement stage. It's something that no building is designed perfectly, and there's always going to be an engineer's judgment required. If you receive an engineer's judgment and it's not signed by the senior member of the product manufacturer, it can't be put on to that seal can't be certified under the FireAS scheme. And something that was brought to attention, how many people have received FireAS certs without an engineer's judgment excluded from the cert? Who's standing over it? It's a mighty question we face daily. So I'm going to go through some common site scenarios that might help you with your inspections during the construction stage. Service spacing. Service spacing is a major one. Most manufacturers have their own requirements, but for this example, I'm using Nullifier as the product I'm most familiar with. So basically, if the M&E contractor hasn't spaced their services correctly, how is the Firestopping contractor supposed to achieve compliance? This is another reason why early engagement and first-of-a-kind benchmarks are so important to have a seamless construction process. Note, it says there, cables can be bundled together into a maximum 100mm diameter bundle, and each bundle should be spaced 100mm apart from each other outer edge. Keep that in mind as we go through this presentation. And keeping on Nullifier, this is a handy guide engineers can use to ensure that the service spacing of their projects are compliant with the tested details. Any deviations from these diagrams result in an engineer's judgment or the M&E contractor moving their service. Each engineer judgment and each time in mechanical and electrical, the contractor has to move their services money. Time is money within projects. And these are items that the design team, I'm not blaming the design team, but it's sometimes their fault for they don't take the opening size into consideration. And it's usually the Firestopping contractor that's getting shredded at by the main contractor for not continuing on, even though it's not a non-compliant cert or non-compliant seal. It's different. Nullifier there for a great guide and a no qualifier for a great guide, but you can see there that some services can be placed closer to one another than others, different service arrangements. We usually give this here to each mechanical and electrical contractor when we start a new project and help comply with the requirements of the manufacturer. So as I was saying about the 100mm cable bundles and 100mm spacing, This is a picture I've taken from a site in Dublin, and as you can see, that doesn't comply for not only for the service spacing but other issues that we can talk about later on in the presentation. So someone's walked away from this here and left this. Like that's why I'm trying to raise the awareness of proper fire stopping. Service supports are another hot topic. So you can see in the right hand side there and in the ETA, there's reference to service supports and the distance that they should be from the opening. They're important as they help prevent services from falling and dislodging the fire stop, especially with cable containment. It prevents them from twisting under fire exposure and damaging the fire stop seal, ensuring that it works effectively in the event of a fire. As you can see to the picture to the left, the white plastic pipe has a service support at the top end of the picture as such, but that's greater than the 400mm quail fire specifier in their drawing, which I've underlined on the right hand side. And the UL classification report there that's also linked within the drawing there, it also mentions that the service support is less than 400mm. So technically speaking, that's a non-compliant seal, and that there's remedial works required by the installation of the service support. And that's not the fire stopping contractor's fault, but it should be the fire stopping contractor's best interest to raise that to them, an e-contractor, if they're a competent enough contractor. So another big topic at the minute is buttering bat. So in product European technical assessments and installation drawings, it makes reference to applying mastic to the edges of the fire bat prior to installing it into place. This doesn't always happen and may require destructive testing to see this issue on site. The image on the left, this is where an engineer has got the fire stopping contractor to cut out a piece of fire bat, and as you can see from the edges of the opening, it hasn't been buttered. You can see that there's no mastic within the concrete slab or on the plasterboard letterbox. This is non-compliant fire stop, and as an engineer who has to sign the EI certificate, are you going to be happy that this fire stop hasn't been installed correctly? And how many fire stops throughout that project weren't installed correctly? Usually if you butter the fire bat and when you're trying to push it into place, there'd be mastic pumping out the back. And on that picture on the left, that was a double bat install. You can see that there's no mastic pushed out from the back. Picture to the right, I've included a picture of I'll brag about it, a Crossfire employee buttering his fire bat, and that is best practice and that is required in order to comply with the European technical assessment. Here's another big one, is the three-sided letterbox. So clients usually wish to save money and they put that down to the responsibility of the architect, structural engineers, down to the rest of the design team. In this project here, the architect was also fit to save money by getting the partition company to install three-sided letterboxes, with the top side of the letterbox being the concrete soffit. There's a 20mm deflection requirement on that concrete soffit, and that fire bat is up tight to the underside of that concrete soffit. Fire bat has got about a 3mm, give or take a few mil, compression allowance. So when that concrete soffit deflects 20mm, what's going to happen at that fire stop? Is the manufacturer of that fire bat going to be happy and stand over it? It's something that we had an argument with on the main contractor, and we actually got quail fire on it. So quail fire created this detail to the right. You can see that there's anti-foam to be installed at the top of the fire bat, which allows for the deflection, but it has to be patters fitted. It's an amazing one that I haven't seen people take on board. Usually they create the four-sided letterbox, and I usually get the main contractor looking at me and funny. And also another thing with the three-sided letterbox, that's from the same site. You can see there that the fire bat was cut. The fire bat's 50mm standard, and that was cut down to about a thickness of 10mm. And as you can see, it's up tight to the underside of the concrete soffit. There's the 20mm deflection allowance within the metal stud partition. So if that wall deflects your 20mm, does that fire stop crack? I would imagine it does. Wall or floor joints. So another item I came across is fire bat specified for linear joints between floors and adjacent walls. Firebat hasn't got a good compression or expansion characteristic, and therefore side raise would be a much better product or similar approved, whether it be Rockwell SP60 or SP120, Lamatherm. The picture on the left-hand side is from a 3-year-old building that Crossfire currently completing remedial projects on. As you can see, Firebat was used for the linear joint. It is actually starting to fall out and it's sticking on by the mastic. When we explained this to the client and showed him what should have been installed, he was looking at me in confusion, couldn't understand why was it done wrong in the first place, considering the building was only 3 years old. The side raise in the right-hand side picture, that's usually installed with a 10-15 mil bigger than the opening. Therefore, that allows for the expansion and contraction of the facade. PVC pipes penetrating concrete floors. That's a real life picture. That's a picture on the left-hand side where, first of all, mastic, normal acrylic mastic was used to seal an SVP 100 or a soil stack 110 mil pipe. You can see in that opening also there's timber put in to try and keep the mastic up. First of all, that there should have been HP mastic used, the high pressure mastic, in order to crush the plastic pipe in the event of a fire. I've included a quail fire detail here to the right hand side where you can see the Firebat used, and then quail coil, which is quail fire's wrap. So that's a non-compliant seal on your left hand side that was installed on sites in Dublin, and I was raised. But so, like, is there a lack of training within the firestopping industry, or why was that installed? With early engagement with the firestopping contractor and M&E contractor, main contractor, avoided mistakes like that there? It's something to be said for the early engagement. Another major one is the CPVC sprinkler pipes. So as you can see, the orange sprinkler pipe on the left-hand side is claried with mastic. The intumescent mastic disintegrates the pipe, causing it to fail prematurely. On the right-hand side of that screen, there is a list of non-compliant mastics for the CPVC sprinkler pipes. And usually there's a special mastic to be used, whether it be the Quail Fire HP mastic, the blue mastic from Nullifier, or I think maybe Protector's got an improved mastic, I'm not entirely sure. So there was a project in Dublin where the mastic did disintegrate the pipe, causing leaks within a live building. And it's something that has to be picked up early on by the fire engineer. For the end of the day, they have to sign an EA and an EC certificate. See here, I have two details between Nullifier and Quail Fire. Nullifier's got the 25 mil annular gap around the sprinkler pipe, and that's the blue mastic, so it is the FS719. And then to the right hand side, you can also see where the Quail Fire's with the HP sealant, and it's also at the 25 mil deep, the full depth of the bat. So it's really important that the correct product is used for the services, ensuring that in the event of a fire, the fire stop seal will act and do its job correctly. So integrity and insulation, this is one I came across a while back. This is my own picture. So we touched on integrity and insulation earlier on in the PowerPoint. How many people have seen metal pipes or copper pipes with metal sleeves on them? The firestopping contractor does a nice tidy double Firebat detail around them, even mastics the joints gaps around the sleeves. Lovely. Well, if this is a fire rated or compartment wall that has to achieve both integrity and insulation, this detail is not compliant. This detail only achieves integrity. So as you can see on the right hand side, the detail is double layer Firebat with mastic, and you can see that the sleeves have been mastic sealed as well to prevent them from having a gap. Down in the bottom left of that drawing, you can see that only achieves a 120 integrity only, and that's been done a lot. So it's fundamentally incorrect. It's not tested and doesn't achieve the correct insulation rating. So how do we get the insulation rating? So the metal or copper pipes must be insulated. As you can see here, there's insulation around these pipes in the depth of detail, and we're achieving EA 120, EA 90, EA 45, and EA 120. It's minor things like these here that are in building sites that are the difference between a compliant and a non-compliant fire stop seal. For many years, I'd have seen that double bat with the mastic seal around the sleeves being installed, and I would have been under the assumption myself that this was correct, when it's wrong. It's fundamentally wrong. It's not only until I got into working at Crossfire that I was reviewing the drawings from Quailfire to realise that, I will go back to the slide here, the mastic seal around the sleeves doesn't give you an insulation rating. I actually had a conversation with a fire consultant on this throughout the week, and it was new to him as well. So hopefully somebody within this presentation can benefit from this slide. And as I say, this is a project Crossfire currently on, so we're looking the pipes insulated. There is a financial impact on the contractor having to insulate these pipes, but we'd rather do the project correct. So other details, there's other details on the ETA and the technical data sheets that a lot of people are not familiar with, i.e. it says there the fewest number of cuts required, and using a suitable tool cut out the FB 750 to the required and measured dimensions. On the picture on the right hand side, you can see that, well, he must have emptied the rubbish bag, to be honest with you, coming to the end of the day to get that there. That could have been created in fewer seals. Is this fire stop on the right hand side, if it was masticed up and tidied up, is it non-compliant? I don't know the answer, but if I were in front of a judge who doesn't understand the industry, the judge may deem it non-compliant. And once again, that is a real life picture that I took my own phone, so it is happening out there and it has to be pulled. It's as I say, I'm trying to raise awareness for the importance of correct and compliant fire stop. And more images here, poor workmanship. So as you can see, with me being on the tools back in 2014, I was aware of where's easy to fire stop and where's not easy to fire stop. Above that trunking, you can see that the fire stop's not fully sealed, albeit someone will say, sure, it's only a small gap. It's not as per the test of detail, and which details the judge going to work with. In the middle there, you can see where there's fire bat pushed out. So that's a double bat seal. On the other side of that wall, when the operative was pushing his fire bat in, he pushed it out at this side, and it's not a full seal, it's not fully sealed. And then on the right hand picture, there's 3 cable trays going through the partition that aren't sealed properly. The lids aren't on them, and the seal doesn't continue down. The lids was never going on them, for there was poor access to get in there. I used a selfie stick to get that picture. And as you can see, there's large gaps there, and it is deemed non-compliant. That is happening within the game, and as engineers happy enough to sign EA and EC certs based on this sort of work. So what is the role of the fire engineer with fire stopping? So the fire engineer decides on the fire rating and the performance of the wall floors as part of the design. The fire engineer reviews and approves technical submittals. He reviews and reviews benchmarks. Benchmarks are vitally important within the construction game. Unless everyone involved with the benchmark know what's required in order to have a compliant install, whether it be mechanical contractors, electrical contractors, partition contractors, and fire stopping contractors, it takes the team to get the compliant seal. The fire engineer inspects the work in order to be able to sign his EA and EC certificate. With some of them recent details I've shown you in this PowerPoint, would you be happy in signing your EA cert? The fire engineer coordinates with other professionals to ensure compliance. And the fire engineer ensures the overall effectiveness and integrity of the fire stopping systems. So as I talked about earlier on, the fire stopper or the fire engineer should be involved with early engagement with the proposed fire stopping contractor, and that takes the full team. So it coordinates with the professionals. It takes a full team to be fit to achieve the compliance. So that's me coming to the end of my presentation now. I hope you've enjoyed this presentation as much as I've enjoyed presenting it. I hope someone within the audience has learned one wee small bit of information that will help them with their daily life. Once again, I'd like to reiterate that it's not my mission to try and persuade you that Crossfire are perfect and that our competitors aren't. I know, as well as myself, there's other fire stopping contractors out there who are trying to raise awareness of fire stopping and the importance of it, how we improve it going forward. we're battling with main contractors in order to be fit to achieve compliant seals. And every time we're talking to them, they think that we're trying to get more money out of them. That is not the case. We are trying to comply with their duty of care in order to fit and install compliant seals, go home at night safe and secure, in order to provide safety to the lives of others. I have my contact details on this slide. So if anyone has a query that it's not answered today, please don't hesitate to drop me an email or drop me a phone call. Or if anyone's got a nice fire stopping project that you'd like to send my way, we're more than happy to take it. So, Sinead, that's me finished. Thank you.